Example 1. Given an angle in standard position, terminal arm quadrant 2. We know all about that, right? We know what that means. Where cos of theta equals minus 5/13. Okay? Angle B is in standard position, terminal arm in quadrant 1. Sine of B is 3/5. So the big thing to remember here is you've got two angles going on. You've got info from angle A, info from angle B, because basically what's going to happen is we're going to end up using one of these sum or difference identities, and they all involve two angles, right? An A and a B. So we have to have info for A and B. So that's the first thing. They are slightly different from what you've seen before, because our previous work, you were just solving for info for one angle, right? Cos of B ends in quadrant 2, cos is 3/5. So that was just one angle. Now we have info for two different angles. So we have angle A and angle B. Angle A is in standard position, angle B is in standard position. So I got to keep my info separately. So here's my angle A, and I'm going to use the Greek A like they do. Kind of looks like a fish in a way, right? I'm going to call this angle A info, and then I'm also going to have angle B info. Okay, what do we know about angle A? It terminates in quadrant 2, right? So it's going to be, this is angle A, and cos of A is negative 5/13. So cos of A equals negative 5/13. I know cos is negative in quadrant 2, so that fits. And I want the exact value of cos of A minus B. So they're basically telling you, go to your formula sheet and look at that formula. So what is cos of A minus B? This is what they want me to do. It's equal to, it's your second difference. That's equal to cos of A times cos of B plus sine of A times sine of B. Okay, so they're asking me to find cos A minus B, which means I have to plug it into this identity formula. It's just a formula, but there's 4 numbers associated with this formula. This number or ratio, this number or ratio, this one, and this one. Now they gave me cos of A, right? So they actually gave me this one and sine of B, this one. Agreed? So I have to come up with this ratio and this ratio. I have to come up with cos of B and sine of A. How am I going to do that? Yeah, so how am I going to find sine? Yeah, so what was so I've got x is 5, right, or negative 5, I guess. R is 13. Find y, agreed? Find y. Okay, you guys know how to do that. Y equals what? The square root of 13 squared minus negative 5 squared. So 169 minus 25. Y is 12. Okay? So that tells me what sine is. So sine of A, remember you're using A's and B's, not thetas anymore, just to, I can't use theta because I have 2 angles, so I have to keep them distinct. Sine of A is equal to positive 12 over 13. Okay? So that's the first ratio that I needed. And now I have to find, so I did him, now I have to find cos of B, right? So I'll just put a little note here. This is what I had to do to find sine of A. And now I want to find cos of B. Okay, what do I know? We have sine of B equal to 3/5. So that means that y is 3, r is 5. Anyone remember what x has to be then? You've seen this triangle over and over. No? This is one of the special triangles, the golden triangles. 4. 3, 4, 5 is a special triangle. 5, 12, 13 is a triangle. There's a few of them. Okay, so we'll prove it. X equals the square root of r squared minus y squared, which is the square root of 16, which is 4. They're the perfect triples, we call them. There's quite a few of them. They work out perfectly, right? Perfectly as whole numbers, whole number size. I'll show you some more later. Pythagorean triples, they're called. Okay, now what do I need again? Cos of B. So cos of angle B is equal to x over r. And what quadrant was this in? It's quadrant 1, so this remains positive, right? Okay. So I needed 4 numbers, 4 fractions, 4 ratios. I have 2 were given to me, and I solved 2, so now I'm going to put this all together and find the exact value of, so the exact value means I'm going to come up with a numerical answer, right? Okay, so I'm going to just repeat what they asked me to do. They asked me to find cos of A minus B, which equaled cos of A times cos of B plus sine of A times sine of B. Okay, so that's going to equal, okay, cos of A, maybe I'll just kind of box off what they gave me. Okay, cos of A, negative 5/13. Cos of B was 4/5. Sine of A was 12/13. And sine of B was 3/5. So we're working with fractions again, right? Don't be super alarmed, because you notice, because you're taking 2 ratios from one angle and 2 ratios from the other angle, you're always going to end up with a common denominator, because the bottoms are going to be the same. So I have negative 20 over 65 plus 36 over 65, which is going to be 1665. You should end up with a fractional answer because you've got ratios that you're multiplying together. Okay? Now, yep.
It's cos A minus B. Do you have? I don't have formula sheet.
Okay, so it was cos A minus B, yep. So cos A minus B, the formula is cos plus sine.
Oh, you got it.
Yeah, yeah, it's tricky, right? These are tricky. So yeah, have your formula sheet in front of me. After all my years of teaching, I don't have these guys memorized. They're just too similar, right? If you look, they're so closely between the 2 addition and the 2 subtraction. I know that I should probably have them memorized, but I don't. So it's a skill that you know how to do, right? You're given one trig ratio. You're finding not 5 other ones. You're just finding one other one. If you're given a cos, you're finding the sine. If you're given a sine, you're finding the cos, right? And then just plugging that info into the formula that's provided for you on your formula sheet. So when you see a cos or a sine or a tan of A minus B, that's the procedure, okay? It's time consuming because it's like you're doing 2 questions in one, right? All right, so that's the other big skill that you'll be using these sum and difference for, to create more special angles like you did for homework, and then to use one of the identities, right? And to find the exact value of one of the given identity that they ask you to explore. Okay. So now just to get, we are going to be using these identities though, the sum and the difference, and then eventually the double angles for other purposes, in solving identities and in solving some, proving identities and solving some more complex trig equations. So just to get more familiar with them, let's take a look at example 2. There's 2 identities here, and it says write expression, because there's nothing to solve, right? There's not an equation with a left and a right hand side. So it just says Simplify each expression. Evaluate when possible. Okay? So sometimes it's possible to evaluate here because they actually give us real values. This we wouldn't be able to evaluate because they gave us x's, right? But simplify. Could you simplify this? Tan pi on 2 minus tan pi on 3 all over 1 plus tan pi on 2 tan pi on 3. Is it possible to simplify that? Anything with trig, I would go right to my formula sheet and see if I can figure out if it resembles anything. Does that resemble anything? This one, right? I think the a minus b. Okay, so to simplify this, I just have to determine, okay, this would be my angle A, right? This would be my angle B. So this would all simplify to tan of A minus B, so A minus B. Okay, interesting, huh? That whole expression simplifies to this. If I had this one and I was expanding, it would expand to this, but it simplifies to this. Can I go further? Could I simplify pi on 2 minus pi on 3? I think so, right? So what would that simplify to? I guess I would need common denominators, right? What's the LCD? 6, right? So this would be 3/6 minus 2/6. Okay, so what's 3 minus 2? 1. Okay, so now I simplify to tan pi on 6. Can that be simplified? Can I go further? I can't simplify anymore, but I could find the value, right? Evaluate when possible. What's tan of pi on 6? 1 over root 3 or root 3 on 3, right? So using our identities, we actually found the value of this. Now, we could have done it a long way too, right? Let's say it was on the exam, and I don't know why, but maybe your mind blanks and you can't find the identity to make it simplified. You could actually plug in tan pi on 2. Oh yeah, you couldn't, right? You couldn't solve that one because that one's infinity. But let's say this was pi on 4, right? Pi on 4, pi on 3. You could actually substitute your values in and find an answer that way too. It's a lot simpler to do it this way though. Okay, what about this one? Sine 8x cos 3x minus cos 8x sine 3x. Could you simplify that at all using identities? What pattern is this one? This one? Yeah, I think so too. It's the sine subtract, right? This is A, whoops, and B. A and B, okay. So this is the sine subtract. So this is sine alpha minus beta, which would be what? Sine of 8x minus 3x. So that would simplify to sine of 5x. And this one we can't go any further, right? Because they just gave us x, so we got to stop there because they didn't give us a solid value for x, so we can't really do anything more on that one. Okay. So you're kind of just playing around with identities and becoming familiar with them and a little more confident. I'm going to give you a little bit of time before we move on to double angles. Try to do in your homework book on 206 where we left off on the weekend, I just assigned number 1. So try 2 and 3. They look a little different and a little the same. It says for number 2, cos is negative 2/3, theta is in quadrant 2. Find the exact value of cos theta minus pi on 4. So it's slightly different from what I did in class, but they're telling you what cos theta is, right? So here's this is your alpha, or your A, and this is your angle B. Agreed? Okay, so take some time and see if you can get through 2 and 3. If you need my help, call me over, just see if you can figure out. So it's a cos difference formula, and this time you've got A and B. They've called A theta, B is pi on 4. So I would set up in the formula first, and then they actually give you one of the values. So it's kind of half done for you, I guess we could say. Just gonna